In this exercise, we are going to translate this formula to CNF. And for this, we are going to use Zitten transformation. The Zitten transformation is about introducing new Boolean variables to basically substitute parts in the main formula. And we will do this step by step. The first step is always to introduce a brand new Boolean variable for the entire formula. Let me call it x1. And now I'm going to assemble the CNF step by step. So I start with x1, which is going to be the first clause in the resulting CNF. And then I'm going to define what is the meaning of x1. Well, the meaning is the formula it substitutes, which is, as you can see, an implication of two other formulas. The two other formulas are compound formulas. Therefore, I'm going to introduce two new Boolean variables for them. For instance, I'm introducing x1 to substitute R implies P. And similarly, I'm going to introduce x3 for the right-hand side of this implication. So finally, the definition for x1 looks like the following: x2 implies x3. Okay, let's keep going. Of course, I also have to define x2. x2, as you can see, stands for R implies P. And in this case, I don't need to introduce new variables because R and P are already literals. Okay, let's continue with x4, where x4 substitutes an implication, and the first part of the implication is a compound formula. Therefore, I need to introduce a new variable x4 to substitute it. And okay, I made a mistake. Sorry. So right now I'm defining x3, and x3 is defined as x4 implies p. Yeah. This is the case. Okay, now I am going to define x4. x4 is a negation of another formula, compound formula, which I'm going to substitute with x5. And finally, last but not least, I must define x5, which is Q and R. Yeah, this is it. So what to do with this formula? It looks quite promising because, you know, the main operators are conjunctions. It consists of equivalences. I have to translate my equivalences to CNF as well. This is really great because I can do this translation to CNF one by one. I can translate the first equivalence to CNF, then the second one, separated from each other. Yeah, so this is what I'm going to do. I'm going to translate the first equivalence to CNF, this one. And let's do it. So this is equivalence. You probably know, I hope you know, that first we need to eliminate the equivalence by breaking it down to two implications. This is the first implication, and another implication, which is the other way around, like this. Okay, so of course, this is not the final CNF because we need to eliminate implications as well. Well, this is not that difficult. We just need to substitute the implication by disjunction, and of course we have to negate the left-hand side of it. And similarly, I have to translate this. I have to translate this implication to disjunction like that. So basically, as you can see, I immediately got close here. So we are heading towards a CNF. But first we have to do with the second implication. Well, The second implication have to deal with in the same way. We must negate the left-hand side of it and use a disjunction here. And of course, we have to eliminate the last implication here, which is a negated implication. You might know the law of contraposition, which makes it easy to translate this to CNF. Basically, we have to keep the left-hand side, then to use conjunction, and then to negate the right-hand side like that. And we are not done yet, because this last part here, this last part is not in CNF, but it is in DNF. Therefore, we definitely need to use the law of distributivity, which is not that difficult to use. Basically, the result of applying the law of distributivity to this subformula results in this CNF, not x3 or x1. Okay, so just to keep the result here, I'm going to move this to the final CNF. So we just translated this equivalence to CNF, which contains 3 clauses. Let me just highlight those clauses with green a little bit later on. But first, let's keep going. So let me take this equivalence and translate it to CNF, very similar to the previous equivalence. Very, very similar, because their structure is quite the same, as you can see. So it will be easy based on the previous step, will be like that. Not x2 or not r or p, and r or x2 and not p and x2. Right? Right. Okay. This is the third equivalence, which we have to translate to CNF very, very similarly. Not x3 or not x4 or p, and x4 or x3 and not p or x3. Okay, let's look at this equivalence here. It looks much easier than the previous ones. Actually, if you look closely, it is just about substituting a literal into another literal. So basically, we can eliminate this equivalence very easily. Just substitute every x4 with not x5. So I mean, here instead of not x4, I'm using not x. Instead of x4, I'm using not x5. Here, instead of not x4, I'm going to use x5. And finally, here, instead of x4, I'm going to use not x5. And by doing so, we just eliminated this equivalence here. Okay, one more equivalence left. This guy. Exactly. Okay. Okay, again, this is an equivalence which is represented by 2 implications. This is the first one, and we have another one. The second one is easy to translate to CNF, because we will got only one clause, since the 2 literals are going to be negated, and here we use a disjunction. The first implication is a little bit more difficult, since we will get a DNF first, to which we have to apply the law of distributivity. So the final result here is not x5 or q, and not x5 or r. And then let's just plug these two clauses into the erased formula. So here, okay, yeah, okay, and this is the end of the solution, because we just assembled a CNF which starts with x1. This is the first clause. This is connected with conjunction with the second clause. This is the second clause, and we continue conjunction, the third clause, the fourth clause. So basically we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 clauses inside the final CNF.